Okay, quick review of our schedule for this week. We only have 4 days. If you look at the calendar on the board, we are spending today, we're going back to section 5.7. We skipped over that when we did chapter 5 because it ties in more with what we're going to do in 11.8. Then Wednesday, Thursday, we will be working on 11.8. Friday, I have slotted for a quiz/test on the second part of chapter 11. Okay, so just a heads up. I'll give you some more details about that as we get closer to that date. We are looking at starting our final review on Friday and getting ready. It looks like our final will be next Thursday, okay, during that block schedule. All right, so before we start section 5.7, quick review of the probability stuff that we did last week. We had two major formulas. One was for the probability of A and B. The other was for the probability of A or B. Do you remember what those formulas look like? I'm going to pause this. I want you guys to talk at your tables. Can you give me the rest of what I have on the board here? What is the formula for P of A and B? What is the formula for P of A or B? All right, who wants to help me out with P of A and B? Let's do that one first. Any ideas? They all start out the same. Good question. He said, are we talking about dependent or independent? We need both of them, right? We have a slightly different version depending on if they're dependent or independent. We started with independent, so let's go ahead and list that one first. What's the independent one? So the probability of A times the probability of B. Yes? That is when they are independent. Okay. How is it different when they're dependent? There's one slight change. I need somebody else answering this one, guys. I gave you time to look it up. You got to have it. Yes? Probability of A plus probability of B. Okay. So it's all multiplication, right? And means you're multiplying. Just like the fundamental counting principle, right? You multiply, 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 all those options together. So if you want both things to happen, you're multiplying the probabilities. What's different when they are dependent is that this has been altered. It's no longer just the probability of B. It's now the probability of B knowing that A has already happened. And if A has already happened and they're dependent events, A has changed the probability of B happening. Okay? They might be very similar numbers, but they're going to be slightly different. What is the probability of A or B? If and was multiplying, or is addition. So we have to add the probability of A with the probability of B. But then there was one extra little piece on there. What was it? Okay, so we didn't always need that. When do we not need this little chunk? When they're mutually exclusive. So if mutually exclusive, this is 0, right? There is no chance that A and B can both happen. So if the two events are mutually exclusive, we don't need this last piece on there. You can certainly leave it on there and just put -0. Okay? But if they are, if they're not mutually exclusive, you have to look at that overlap, because we counted that event and that event over here. And so the overlapping part where both A and B occur has already been counted. All right, we've counted it twice. We counted it in the A group, we've counted it in the B group. So we have to subtract one of them off. Okay? All right, take a look at your homework from last night. Question 21. Come on. I guess it's not letting me extend my page there. There we go. Okay. It says a math teacher gives her class 2 tests. 60% of the class passes both tests, and 80% of the class passes the first test. What percent of those who pass the first test also passed the second test? So how would we define our events A and B? What's the first event that has to happen? We have to pass the first test, right? So if we think of this in terms of a tree diagram, we might pass the first test or we might fail the first test. Yes? Okay, what's event B? What's the second thing that has to happen? Whether we pass the second test or not, okay? So we branch off. And then to get all the way out one of the branches, what did we do with the numbers along the way? Come back to that question in a minute. Let's fill in the numbers that were given. It says right here, 80%, I did redo my board before I started recording. 80% of the class passed the first test. So if this is 80%, this would be 20% down here? Okay. Now, the other piece they told us is that 60% of the class passed both. That means we have already gone through passing the first, passing the second, and we've gotten out to here. Does that make sense? So they're giving me that final answer, and they're asking me what percent of those who passed the first test also passed the second. So given that we've passed the first, what's the probability I pass the second? That's this number here. Okay? But they haven't given that to me. So we can set it up just by looking at our branch here. We can set it up using our formula. So if we started with our formula, the probability that we pass first and second, okay, is the probability that we pass the first times the probability that we pass the second, given that we pass the first. Okay? So what was the probability that we passed the first test? 80%. What was the probability that we passed both tests? What was the probability that we passed both? That was the 60%. And this was our unknown, right? So we're taking 0.80 times something to get 0.6. Well, again, if you look at your tree diagram, remember you have to multiply along the way. So we have to go this route and this route to get out to here, right? So we would have to take the 0.8 times something to get 60%, 0.6. So did you have to write the whole equation out like this? No, we could have looked just at our tree and figured out. Okay? The key is if both things happen, if it's a probability of passing both tests, that's at the end of the branch, right? That's all the way out to the end. So to solve this, what would we have to do? To solve for x. Everybody, come on, solving for x, what would we have to do? Divide out what? The 80, the 0.8? Okay. All right, let's move on to section 5.7. I do want to collect your homework from 11.4b, so go ahead and have that at your tables. So in order to help us with some probability stuff that we're going to do tomorrow, we have to know how to expand a binomial, and we have to know what Pascal's triangle is. Has anybody heard of Pascal's triangle before? No? Okay. So we are going to look at Pascal's triangle. We're also going to look at using this binomial theorem to help us expand things. Okay? And when we talk about expanding a binomial, we're talking about taking two terms, a plus b, x plus y, whatever those two terms are, and raising it to a power. So if I said I want you to raise it to the 20th power, you'd be here a while, right? Today we're looking at what's a shortcut. How can I get that expanded without actually having to do all of that multiplication? Because that would take you a long time. You'd have 20 of those that you'd have to FOIL in pairs and then multiply those answers together and multiply those answers together. It would take a while. Okay. So Pascal is famous for his triangle. We're going to look at where this triangle comes from. We'll come back to this. It says we can use a pattern of coefficients and a pattern for our powers to expand a binomial. Okay. Before we finish that top blurb, I actually want you to try a couple. We know that a plus b to the first power is just a plus b. Yes? What happens when we square it? That means we're taking a plus b times a plus b. Yes? What do we get if we FOIL that out? A squared. Think about what that middle term is going to be. Because you're going to get an AB here and you're going to get an AB here, right? So you're going to have two ABs, all right? And then last term, B squared. Okay? Now, if I wanted to take a plus b and cube it, that means I have 3 of those a plus b's to multiply together, right? But I've already multiplied 2 of them together. So I would have to take this answer and times by another a plus b. Okay, don't worry, we're not going to do all these. Okay, but I do want you to finish the a plus b cubed. So if we take a and distribute it to all of those pieces, what do we get? A times a squared. Everybody, come on. A cubed. A times 2ab. 2a squared b. Okay. A times b squared. ab squared. Yes? Okay. Now I go through and I multiply b to everything. B times a squared is another a squared b, right? I already have a term like that, so I'm going to line those up together. B times 2ab gives me 2ab squared, and b times b squared gets me b cubed. And if I put all my like terms together, these are like terms, these are like terms, I end up with a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay? So you can see that every time I have to multiply another a plus b in, it takes some work, right? And this expression keeps getting longer and longer and longer. So if I said to take a plus b to the 20th power, you'd be at it for a while. Okay? We don't want to have to work that hard. So, a couple things I want you to notice. We're going to focus on what is the coefficient pattern, and we're going to focus on what is the power pattern. Okay? So looking at my powers. In this first one, Both are to a first power. Yes? In the second one, I have a 2 here. I have a 2 here. My middle ones actually add up to a 2, right? And that came from squaring. When I'm cubing it, I have a 3. 2 and 1, these add up to 3. I'll do it down here. 2 and 1. 1 and 2, these add up to 3. I've got a 3 there. Yes? Now, focus on just the A piece. Look at the power of A. In this last one, I start with an A cubed, then I have an A squared, then I have an A to the first, and then I really have an A to the 0, right? But anything to the 0 is 1, times it by 1 isn't going to do anything. So I don't usually write it in there. Looking at the B term, I have no B's in the first one, B to the 0. Then I have B to the first, B to the second, B to the third. So there's lots of patterns in here that you can use to create your answer without actually doing all the multiplication. Okay? All right. So going back up here, that's the focus in this line. You have A to the nth power. If I'm raising this to the 20th power, my very first term is going to have an A to the 20th. My next term would have an A to the 19th. My next term would have an A to the 18th, and it would keep going down. Okay? So my A's have powers that are going down each time. N, n minus 1, n minus 2, all the way until you get to no A's. And your B's go in the reverse direction. They start with nothing and work their way up. Okay? All right. So how do we get from all this to Pascal's triangle? We are going to look at taking A plus B and raising it to the numbers from 0 to 4. We've already done some of them. All right, so if we raise something to the 0 power, we said that's just a 1, right? So if A plus B to the 0 power, we're just going to get a 1 here. All right, this was A plus B to the first. We've done that one. We talked about the square one. We talked about the cube one. We didn't do the fourth one. It's here for you. I want you to look at the powers that we talked about. Does that pattern work for A plus B to the fourth? We start with a 4, then we have a 3, 2, 1, 0. Okay? And our B's go in the reverse direction. None, 1, 2, 3, 4. Okay? So that pattern of powers is continuing. If we take out all the variables and we just focus on the coefficients, I have a 1 here. Both of my coefficients there are 1s, so my next row is just 2 1s. Then I have a 1, a 2, and a 1. Okay, so this part right here is just the coefficients. I've ignored all of the variable pieces. This is Pascal's triangle, or the start of it. Okay, and we're going to be able to use Pascal's triangle to help us generate our answer. All right. So how Pascal's triangle is created. You will notice that it starts with a 1 on top, and the outsides of each row are 1s. Yes? Every number inside of that is created by adding the 2 above it. So, for example here, 1 plus 1 gets us a 2. Okay? 1 plus 2 gets us a 3. 2 plus 1 gets us a 3. 1 and 3 gets 4. 3 and 3 makes 6. 3 and 1 makes 4. And we can just keep generating every row by adding the numbers above it. Okay? So what would my next row be if I had to create the next one here? I have to start and end with a 1, right? And then I add the 2 above it. So 1 and 8 gets me a 9. 8 and 28. Okay. Add 28 and 56. 84. Add a 70 to 56. And what do we get here? Another 126. That gets me 84, 36, and 9. And then we end with a 1. Yes? Do you see the symmetry within the row? Right? Forward and backwards, they're the same. So if you know the first half of the row, you can get the second half of the row. Okay. All right, so how we're going to use this, I might have to redo my board here. We're going to start out with a very basic binomial. It's just a plus b. Eventually, we are going to move to where that's 2x plus 5 or 4x minus 3y. Okay, so we're going to have more pieces involved in it. And what typically happens is students start writing this out and they didn't leave enough space, and pretty soon it's all jumbled together and they can't tell where their terms start and end. So I am going to have you write out each of the terms of your answer as a separate row. And then once we get each of those terms really simplified to its final form, then we'll put it all together as one big polynomial. Okay? So my first step is to look for Pascal's triangle. I need those coefficients. All right? So if I'm raising something to the 6th power, I need the row in Pascal's triangle that starts with a 1 and then a 6. Okay? So that very first row that we just have a 1 in, we call that the 0th row, right? Because we took a plus b to the 0th power. So your first row is really the second row of Pascal's triangle. So go down to the 7th row in there, which is 1, 6, what? Okay, I want you to write those numbers out vertically. Okay, so 1, 6, 15, 20, and then it goes back down, right? 15, 6, and 1. Yes? Okay. Now, for our first example here, we have A just being a plain A. My very first term is just a plain A. So I'm going to take that A, and we said powers start where? For your first piece. Do they start high or do they start low? They start high. So I'm going to have A to the 6th. I'm going to have A to the 5th, A to the 4th, and it's going to keep going down by 1 till I get to A to the 0. Helps if I can count. Okay. My next piece is a positive B. So each of these is going to need a B. But what happens to my powers for the B's? They go in the opposite direction. So I'm going to start with 0 and go up 1 each time. Okay? As I said, this one's a pretty basic one. We don't have a lot of calculations to do. We do need to recognize that anything to the 0 power is 1. So when I see this, b to the 0, I'm going to think of that as a 1. And down at the bottom, a to the 0, I'm going to think of that as a 1. Okay? To get the terms of your answer, you're simply multiplying these. Each of these rows is going to get me one term of my answer. Okay? So my first term, I have 1 times a to the 6th times 1. It's just a plain a to the 6th. Okay? My second term, I have 6 times a to the 5th times b to the 1st. That's 6a to the 5th b. My next one, I have a 15 a to the 4th b squared. Yes? Now I'm not going to keep writing these out because there's really not much to simplify here in this first example. But we do need to write our final solution out. So my first term was an a to the 6th, right? My second term was 6a to the 5th b. What was my next term? Okay, next term. Here. I need a 20 a cubed b cubed. Then I need a 15 a squared b to the 4th. I need a 6 a to the 1st b to the 5th. And I need b to the 6th. Okay? So my coefficients came from Pascal's triangle. My powers are following that pattern, right? Where the a is going down in 1 degree, the b is going up. Okay? Now we have to look at what happens when it's not a plane A. What happens when it's a 3x? Okay? How does that change things? All right, so the theorem that we are using is called the Binomial Theorem. The little p's there, p sub 0, p sub 1, p sub 2, those are the numbers in that row of Pascal's triangle. Okay? And then we've talked about the pattern for your powers. What kids tend to forget is, what do you do when it's not a plane A and B? We got it down when it's A and B. What if we change those things? So if you have a negative here, I want you to consider B as -2. Think of that as x plus a -2. Okay? If you have coefficients within each term, like the 3x, it's not just a plane x or a plane A, now it's a 3x. You have to keep in mind that that is your A, so when you raise it to powers, you have to raise the 3 and the x to that power. Okay? That's why it's going to start taking up full rows. All right? That's why we write it out as each term being a separate row instead of trying to throw all of it in as one. All right, so let's expand 3x minus 2 to the 5th. All right, so if we have raising to the 5th power, my Pascal's triangle row needs to start with what? 1, then a 5, right? So find your row. It's a 1, then a 5, then what? A 10, and then it starts going reverse direction, right? 10, 5, 1. Okay? So those coefficients always have to get multiplied into those terms. My A value is a 3x. So I'm going to multiply by a 3x to all of these. And I'm going to put my powers in. We're going to start with our highest power, which is a 5, and work our way down. Okay. What is my B term? My B has to be the -2. Yes? Okay. So my next thing I have to multiply in B. So all of these are going to have a -2 getting multiplied. And we're going to put our powers in just a sec. And our powers for our second part, for our B piece, start with 0 and go up. Okay. All right. Now we have to just figure out what each of these rows is. It's going to be at one of the pieces of my final polynomial. Okay. So my first row, I have 1. I have 3x raised to the 5th power. What is 3 to the 5th power? Use your calculator if you don't know. 3 to the 5th. 243. And x is being raised to the 5th as well. Okay. And then what is negative 2 to the 0? That's a 1. Okay. So if I take 1 times 243x to the 5th times 1, I get 243x to the 5th. Okay. That's going to be the first term of my answer. My next term, I have a 5. I have a 3x being raised to the 4th power. What's 3 to the 4th? 81. So I have an 81x to the 4th. And then negative 2 to the 1st power is negative 2. And if I multiply all those, let's use some common sense here. What's 5 times negative 2? 5 times negative 2 is negative 10. Negative 10 times 81 is negative 810. X to the 4th. Okay, that's the second term of my answer. Next one, we've got a 10. We've got a 3x being cubed. 3 cubed is 27, so 27x cubed. And then I have a negative 2 squared. What happens when I square a negative? Comes out positive, so I have a positive 4. So what's 10 times 10 times 27 times 4? Okay, so our next term is a positive 1080x cubed. All right, next row. We have another 10. We have a 3x that's being squared, which turns into 9x squared. And we have a negative 2 that's being cubed. What's negative 2 to the 3rd power? Negative 2 times negative 2 times negative 2. Negative 8. All right, multiplying. 9 times 8 is 72. 72 times 10 is 720. And it's negative. So negative 720x squared is my second term. All right, next row. We've got 5. 3x to the 1st is just 3x. Negative 2 to the 4th. Is that going to be positive or negative? Everybody, come on. Positive. All right, 2 to the 4th is 16. So now I need 5 times 3 times 16. 15 times 16. What do we get? What do we get? 240 with 1x. 240x. And last piece, I have a 1. What's 3x to the 0? Careful, 3x to the 0 is 1, right? Anything to the 0 is 1. Negative 2 to the 5th. Negative 32. All right, so my final answer there is negative 32. So I have all my pieces. Now I just have to write them out in one string. Okay, so final answer. We have 243 x to the 5th minus 810 x to the 4th plus 1080 x cubed minus 720 x squared plus 240 x minus 32. Okay. Questions about the process? Taking 3x minus 2 and writing it out 5 times and doing all the multiplication. This gets easier the more you try it. You'll start finding ways to simplify things. All right, for our last question, I'm going to change your question just slightly. I want you to add an extra little y after the 3 on your notes packet. Okay, so it's 2x minus 3y to the 4th power. All right, so take a minute. Find your Pascal's triangle row that you need. And you might start memorizing those first few rows after a little while because we use them a lot. The row has to start with what? Well, it has to start with a 1. What's the next number in that I want? A 4, right? I'm raising it to the 4th power, so I need the row that starts 1, 4. Okay? So 1, 4, then what? 6, 4, 1. Yes? Okay. My next piece. I have to take my A term, and A is 2x. So each of these needs a 2x. Bless you. What's the first power going to be? A 4. 4, 3, 2, 1, 0. Okay. Next term is what? Be careful here. Next term is negative 3y. Yes. Okay, so each of these needs a negative 3y. And remember, the second term, the powers go up. All right, I'm going to pause the recording. I want you guys to try to simplify each row at your table. All right, check with each other. Make sure you're multiplying correctly. All right, let's check. Top row, we've got 1 times 2x quantity to the 4th power. 2 to the 4th would be 16, x to the 4th. This is a 1, right? So my first term in my answer should be 16x to the 4th. Yes? And if you don't want to write it out at this end of this first row and you want to just start writing your answer, that's fine. Okay? Next row, we have 4 times 2x is cubed, which gets me 8x cubed. I'm timesing it to negative 3y. So I have 4 times 8, that's 32, times negative 3 gets me negative 96. Yes? And then my x and y's, I've got an x cubed and a y to the 1st. Okay. Next row, we have 6 times a 2x squared is 4x squared. A negative 3y squared is 9y squared. What's 6 times 4 times 9? What is it? 216. So I have positive 216 x squared y squared. Okay. Next one, I have a 4 times a 2x. And what's negative 3 cubed? Negative 27y cubed. So what is 4 times 2 times negative 27? Okay. My variables, I have x to the 1st and y cubed. Okay. And then my last row, I have a 1. 2x to the 0 is also 1. And I have a negative 3y raised to the 4th power. What does that get me? 81y to the 4th. So final answer there is a positive 81y to the 4th. Yes? Okay. So tomorrow when you come into class, we are going to have you fill out that learning goal in Schoology. Rate yourself on things. For your homework today, you guys are going to do questions 12 through 19. Okay, I know they take a while, so I haven't given you very many. 12 through 19. And then you should have a green worksheet. We did one side of it a while ago, but I didn't collect it because I was going to have you go back and do the other side. So I'm going to have you work on that tonight as well. Okay?